Hello and welcome to Solve Some Homework Problems video. In this video, I will solve problems that are very similar to the homework problems that have been assigned to you. In fact, they are homework problems, they're just ones that haven't been assigned. But they are very similar to the ones that you'll work for your homework. And I thought by working through these on this video, it might give you maybe a leg up on correctly answering the questions on your homework. I will be answering homework, not homework, but problems from the back of chapter 16, and I will be solving problems 22, 26, and 32. I'll do that by hand, and I'll also quickly show you an Excel spreadsheet. I will not be posting the Excel spreadsheet solutions. I think that makes things perhaps a little too easy, and part of your education process is to, gosh, I hope you struggle a little bit, because when you're struggling, you're learning, as long as you're not struggling too much. So here we go. Problem 22, let me read it to you. You should have it in front of you. But the question is, determine the APY, or annual percent yield. That's the I sub A, the effective interest, for an APR of 10% for quarterly and monthly compounding periods. Let's first look at that, solving that by hand, and then we'll look at solving it by using Excel. Here's the setup. We have an APR of 10%. Quarterly, the APY, now you're going to have to go back. I'm not going to revisit this. We did this in class, and it's in your textbook at the very first of chapter 16. We did this, gosh, 2 weeks ago anyway. The formula to find the annual percentage yield is equal to 1 plus the APR divided by the number of compounding periods per year. Quarterly means there are 4 compounding periods per year. And then I will take that term to the 4th power and subtract 1. And that is, you can do the math here, 0.1 divided by 4, that would be 2.5%. That is the interest rate per quarter. Add that to 1, that's 1.025 to the 4th minus 1. I'm running out of sheet here. Let me scoot this over just a little bit. And that turns out to be 10.38%. Once again, you may look at that and say, gee, isn't that close enough to 10%? And the answer is no, it's not. While I don't like pennies, fractions of interest rates can indeed make a huge difference, especially if the kind of dollars we're talking about are hundreds of thousands or millions or tens of millions of dollars. Okay, what about monthly compounding? Quarterly, we had 4 compounding periods per year. In monthly compounding, we have 12 compounding periods per year. The APY for this is 1 plus the APR, and I'm going to go ahead and put it in, 0.1 divided by 12. That would be 1/12 of a percent or 1/12 of 10% per month. Take that to the 12th power minus 1. And that turns out to be 0.0083 if you do the 0.1 divided by 12. So we get 1.0083 to the 12th minus 1. And I can tell you, you know, in all these problems, and some of you have fallen a bit short, you should be able to look at your answer and tell that it makes sense. Be able to confirm that, a rough estimate, gee, that makes sense. Well, for this problem, I can tell you that the APY will be greater than 10.38%, because the more often you compound your interest, the greater the APY will be. And it turns out that the answer here is 10.47%. Not a huge difference, but a significant difference. One last comment on this APY, and I probably won't mention this in class, but you know, you can, I talked about in class a couple of weeks ago, talked about daily compounding, which is what happens on your credit cards. You know, there is such a thing as continuous compounding, and there's an asymptote that this reaches the limit of this APY as the number of compounding periods approaches infinity. And we don't want to get into the math of that, but suffice it to say that there is such a thing, and it actually makes calculations quite straightforward. But we're not going to get into that right now. Okay, so that's homework problem 22 by hand. Let me share my screen and very quickly show you this on the computer in Excel. And so there's the formula. APY is 1 plus APR divided by C, where C is the number of compounding periods. That whole term to the C power, and then subtract 1 at the end. So the APY here for quarterly, I'm going to type this in, and the magic of video, you can watch it later. Watch me do it again. I'll only do it once. This will be equal 1 plus, and then the APR. And so I can drag the formula down. I'm going to say the APR is in B1, $B, $1, divided by the number of compounding periods per year, then taken to the power of the number of compounding periods per year, and finally minus 1. And that will give us, we said it was 10.38%. That should be 10.38%. Oh, I've got a typo. Oh, I left off a parentheses, and I want it right there. My apologies. I need to close this inside, and then I need to close this outside one that contains the 1 plus. There we go. That should work. And there it is in decimal form. If I go up and change this to percent, and then give it some decimals, 10.38%. There we go. Now I can drag this formula down now, and it should give me the 10.47% for the monthly compounding, and there it is. So we can, it's much easier, obviously, always, all things except the very simplest are going to be easier using Excel. And there's the answer. Let us now move to looking at problem number 26. And 26, let me read it to you. Determine the monthly payment for a 30-year real estate loan with an APR of 8.5% and an initial principal of $200,000. How much interest is paid over the life of the loan? Aha, how much interest is paid over the life of the loan? You'll be shocked, maybe, but it's a good calculation to make, especially on real estate loans. It's going to be very painful. When you buy a house and you borrow money and you get a real estate loan, You know, you'll be on the, some of you will be on the flip side of that, constructing the home and selling it, but when you're buying it and you see the how much interest you pay, it's rather shocking. Here we go. Let's look at it by hand first, and then we'll quickly look at it using Excel. Okay, how many periods do we have? Well, this is monthly. The question says determine the monthly payment. We have monthly cash flows. We have 12 times 30 years, 12 months per year, or 360 periods, or 360 months. This loan will be for 360 months. The A that we find will be an A for 360 months. Our APR is 8.5%. Now remember, APR is annual percentage rate. That's an annual rate. To find the monthly rate, it doesn't say this in the problem, which is confusing. I understand that. But the implication with monthly interest, with monthly cash flows is that we have, first of all, we have to have a monthly interest rate. And the implication here is that this is compounded monthly. That's an assumption that's implied in the problem, and it is something that you are welcome to do. We'll take the 8.5% in decimal form, 0.085 divided by 12. That means that we have 0.71% per month, 0.0071 or 0.71% interest per month. That is our I. So we have a P of 200,000. That's the initial principal of the loan. We want to find A. A is equal to P, 200,000, times A given P. The interest rate is 0.71%. The number of periods, 360. If you do this by hand, you'll have to use the formula, because you might notice in the back of the text, there is no table for 0.71%. Now you can get 0.75%. You could do some linear interpolation. It's not linear, but that's a good approximation to find this term. But otherwise, you're just going to have to use the formula for A given P. I'm not going to go through that. I assume that you can find that if you need to, and I will give you the answer. It's rounded. I'm rounding up. I'm getting rid of the penny. I keep the pennies in my calculator, but I'm rounding up for display here, $1,538. Those are the monthly payments on the $200,000 loan. Given APR of 8.5%, compounded monthly, 0.71% per month for 360 months, that is our monthly payment. Total payments. What are the total payments? Well, the total payments are the $1,538 times the number of payments times 360. That represents the total dollars that you would pay on this loan, including the principal and the interest. The total dollars, you might be shocked to know, $553,618. You borrowed $200,000. In all, you pay back $553,618. Okay, so the question was, how much interest is paid over the life of the loan? Well, there's the life of the loan. How much interest did you pay? Everything that's not principal is interest. We'll take our total payments, $553,618, subtract the principal, pretty easy calculation to make. $353,618. Well, I did that without a calculator. You paid over the life of this loan $353,618. That's not quite twice the principal in interest, but it's way up there. So much more interest than principal paid on that loan. You kind of have to let that sink in a little bit. When you buy a home, if you kept the mortgage to the very end, it could be quite expensive in terms of interest. And that's one of the reasons that you'd probably like to have that $353,000 in your pocket. That would be a very nice thing, which is why it's always better. It's hard to pay cash for a house. I've not done that myself. But if you could pay cash for anything other than borrowing money, do it. Okay, now let's look at let's share my screen. We'll look at the Excel equivalent very quickly. Here we are. The monthly interest rate here is very easy. It's the APR divided by 12. There's our monthly interest rate. I said 0.71% per month. It's 0.70833. Our monthly payment, that's easy to find, right? That's a PMT. I'll say minus PMT. The interest rate, this guy, number of periods, right here, present value, right there, the $200,000. Here we go, 1537.83. Total paid is equal to that number times the number of periods for the life of the loan. There's our 553,618. And the interest then, the total interest that was paid on this loan is the total amount paid minus the original principal. And that's the 353,618. There you go. Much quicker again in Excel. And of course I had this set up ahead of time, but I'd again encourage you to use Excel, and this number is really big. That's just the way it goes. That number is really big. Finally, let's look at this. Let me turn my page here. Let's look at this last question because it's one that really stumps people a lot. You can brute force this answer. I'll be giving you, I've posted a spreadsheet that I'll talk about in class. I did talk about in class about mortgages and amortization schedule. You can brute force this answer from that, but it's much easier to answer than that. You just have to really understand this economic equivalence thing and this moving money thing. So here's the question. It's question 32. Determine the outstanding principal balance on the loan in problem 26, that's the one we just did, after 120 payments have been made. So what is that really asking? Well, let's look at it by hand first, because I think that's very descriptive of this problem. We're chugging along and we've been making these payments, ka-chunk, 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 the $1,538 payments all along here. We've made 120 payments. All of this is in the past. All of the activity back here is sunk, right? We talked about sunk costs. That's sunk. And now, so as we're paying this loan back, we would have from 120, starting with 121 to 360, that would give us a 240 payments remaining. We've made 120. We got to make 360 payments to pay this loan off. We've made 120 of them. 240 payments remain. The question that is asked is, determine the outstanding principal balance on the loan. And in essence, the question is, if you had to pay off, if you could pay off your loan, you hit the jackpot and you want to pay off your loan after the 120th payment, how much do you owe to the bank at this point? How much money would you be able to pay the bank and get and eliminate the loan, pay off the loan? Well, it's really quite easy. You have these cash flows remaining. What you want to find is the present equivalent amount, the economically equivalent amount of all of these here right after you made your 120th payment. You want to find P. Finding P is very simple. P is equal to A, 1538, times P given A. That interest rate was, remember, 0.71% or 0.70083%, and the number of periods remaining, 240. This brings all of these 240 individual monthly cash flows of $1,538 back to the present, where the present, remember, relationship between P and A, the present is one period, and the periods for this problem are months, one period prior to the first A. There's our first A in this sequence. One period prior is at 120, right after you've made that 120th payment. And I'll let you look that number up. It turns out, now remember, this is 10 years down the road, right? 12 months per year. We're at month 120. So this is 10 years down the road. You would think that since you borrowed $200,000, that 1/3 of the way through this process, you should be down to what, maybe $130,000 that you owe, something like that. Well, I hate to disappoint you, but you owe $177,205. Why so much, you ask? Well, it's that much because almost all of these early payments back here, and as we saw in class, almost all of these payments are interest. It's just painful. The interest is very high at the beginning, and it only goes away down here near the end when almost all of your payments go toward principal. There you go, there's that. Let's now come back and look at this in a spreadsheet just to demonstrate how straightforward this is on the spreadsheet. And here we are. I have some of the same information as before, just because I wanted to carry it forward. I didn't carry it forward. I mean, there's my monthly interest. Let's make that a percent. I like to see it that way. My monthly payment rate for periods, present value. There's my payments. Now the number of payments that I've made is 170. The number of payments remaining will be the number to begin minus the number of payments made. We have 240 remaining. And the balance remaining then, remember, is a present value calculation, equal negative PV. The interest rate stays the same. Number of periods now is 240. And our payment is our monthly payment. And there we have it, $177,205. That's how much we we still owe on this loan. Okay, so your homework problems are just like these, and you should be able to hopefully use this as a springboard to look at the difference in your homework problems and these problems, mostly number differences, and then use it to help you with the homework. There are also homework questions that I didn't cover. So those are the ones that you'll have to give some extra thought to. And I challenge you to get them right, because I'll feel really good and you'll feel really good too. That's all for this video. And I will, I don't know when I'll either see you in class next Tuesday, or I'll have another video to help with something else along the way. Okay. Have a wonderful day.